Okay, tomorrow we're going to delve into more multi-steps, but we're going to throw in some of the strip diagrams for multiply and divide that we never did. And then I'm thinking tomorrow they'll do a fun scavenger hunt activity in partner. So tomorrow is another day of just practice. With the assignment y'all did Monday and then the assignment we'll do Friday, that gives you your 2 assignments. And to me, it's better to do good quality teaching than, a lot of assignments. All right, so ask them what it means when you have multi-step problems. Multi-step. Multi means more than one. So multi-step means all of these have more than one step to them. All right, so I'd have the girls read about Gina, and they read about Gina. And then you might say, okay, boys, what do we need to do? Summarize for me. We need to draw. Draw what? Strip diagram. For what? To show. Number. Number of what? Mushrooms Gina put each salad. Okay. Well, we want the mushrooms that she put in each salad. Do we know the whole amount of mushrooms? Or do we have a whole amount? Yes, we do. It's right here. She has 42 mushrooms. That's the whole amount. And so I'd make them remind you, and I think I did this the other day on y'all's paper, but that a strip, I can't keep up which class is which, so strip, always tear a strip of paper. A strip diagram, one strip represents the whole amount, and we are going to write that one time. And the other strip represents parts. So I'd get them to write that. And then we agreed that that's a whole amount. So we've got 42 mushrooms. What else do we know? She put the mushrooms into 6 salads. All right. Do y'all see any key? All right. So we know we're missing parts. Are parts bigger or smaller than the whole? Parts are smaller. All right. Well, what are the 2 operations that help us get smaller in math? Subtract and divide. Good. Because when you take away, you get less. And when you divide or split your Cheetos, you get less. Are there any words or any keys to lead us to one or the other? Yes, right here, same. If it's the same, that's fair. And the only time they care if we're fair is if we share. Fair share. That's a huge hint for division. Each salad has the same amount of mushrooms. Key word, each. Each is either group each together or take each group apart. Well, the division matches the missing parts. So this is division. How do you draw it? Well, you have 6 salads, even or odd number. It's even. How do you know? Well, I can think of 2 reasons. They know because even numbers end in 0, 2, 4, 6, 8. Or if you split 6 in half, it can be split into half perfectly. 3 plus 3 is 6. And that helps us divide this. 6 boxes, and ask them, what do y'all think the 6 boxes represent? The salads, right. What do we know gets put in the salads? Mushrooms, same amount. Well, that's when it looks like this. You get one, 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 you get one. You get one, 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 you get one. Like passing out cards. So there are 6 boxes for 6 salads. How many mushrooms go in each salad? We do not know. So I'm going to write the letter M. This is algebra. When we're putting in a letter or a symbol, we don't know the amount of mushrooms in each salad, but we do know there are mushrooms, and there are the same amount. If you see that fair share, the same, then each box should be the same size, same shape, congruent. All right, I know I need parts, and I know each part is the same. We've decided it's division, so we're going to write an equation. Equation, it looks like a bully word, but really equation is just trying to spell out equals, because equations are sentences with equal signs. So how do we solve it? Well, we're going to do 42 divided by 6, and it's going to equal M. What does M stand for? The mushrooms. All right, so who do we know goes with division? Multiplication, that's right. So I could be thinking, what times 6 equals 42? So this way is divide, but opposite way would be multiply. So think of our sixes. 6 plus 6 is 12. So 2 more sixes, that's another 12. That's 24. If I do 2 more sixes, I'm adding another 12. If I add 2 more sixes, I'm adding another 12. That's 48. So that's too many. So maybe I should 1 more 6. There it is. So it's 2, 4, 6 plus 1, 7. Can they use their multiplication table? Yes. On a test, can you use it? Yes, if you make your own. They could use their flip chart, in class. But I honestly would be getting my kids away from always looking up the answers and start showing them how to find them. If they know multiplication is repeated addition, then repeat 6. Use the doubling to help you. All right? So the answer is 7 mushrooms. All right, boys, read us about baseball. So they read. Girls, what are we looking for? I want y'all to summarize. We're supposed to draw what? Strip diagram. Why? To find or to solve number baseballs league bought. Do we have a whole amount of baseballs for the whole league? The answer is no. There are 9 boxes, and there are 36 baseballs in a box, but do you know the whole amount that the league, or you could ask them this, the baseballs that the league bought, do we want some of them or all of them? Well, we want all of them. So if we want all of them, we need to get a whole amount. We're missing the whole amount. So
I can't see.
You could draw a symbol.
Throw that away.
I don't know that I just drawed. I don't know that I drew a baseball. Is that a baseball, Kevin? Right there. All right, so my baseball, that's the missing whole amount. So I'm missing the whole. Is the whole big or small compared to parts? It's big. What are the 2 ways to get big in math? Add or repeatedly add, which is multiply. No. All right, so what do I know? They bought 9 boxes of baseballs. So 9 parts. And see, that's too big. Hold on. Good thing we have pencil. Ask the kids if they think the 9 parts should be congruent. 1, 2, 3, 4, 5, 6, 7. If the parts need to be congruent or different sizes. And then ask them to justify their answer. They should be the same because each box contains 36. So if each one holds 36, they each hold the same amount. So 9 boxes. They need to be congruent, same size, same shape. We're not perfect, but, see, I use my eraser to get close. And I know each one holds 36. So in each one, we write 36. Well, what do you see when you write that? Hopefully you see repeated addition. Well, that's multiplication. And how many times do you see 36 repeated? 9. Right, so to solve this, we're going to do 9 groups of 36, and that's going to equal the whole amount of baseballs. Again, it's algebra when you're missing a number and using a symbol.
Eat your chicken.
And it's an equation with the equal sign. It's a number sentence because sentences have punctuation. So then we're going to solve it. So we're going to line up 36 times 9. Well, this is 9s, right? Let's do our 9s trick. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so we want 9 times 6. 1, 2, 3, 4, 5, 6. That's 6 groups of 9. 54. We carry because there's a number waiting. Then we're going to do 9 times 3. Well, 3 9s is 27. Plus 5. 28, 29, 30, 31, 32. Do I need to carry? No, because there's no one left to multiply 9 against. So we just write 32. So there are 324 baseballs in all. All right, class, read us about Fran all together. And if they're not paying attention or they're reading bumpy, start over. That's what I do. That's why kids know that they better just do what I say because they're going to end up doing it again anyway. All right, what are we going to do, or what do we need to summarize? We're going to draw, strip diagram, find total amount paid for shirts, socks. All right, well, if you want the total amount, Kevin, if you want a total amount, is that some of it or all of it? Oh, it's all of it. Well, is all of it a part or is all of it a whole? The whole amount. Okay, what two operations give us big whole amounts? Kayla, add or multiply. Good job. Yeah, to get big, you got to add or multiply. All right, so if we do not know the total amount, we can put a symbol. Why do y'all think I used a dollar sign? Well, we're talking about money. All right, what do we know? What are the parts? And let's go ahead and label this. This would be whole. And these are our P, our parts. And we're not writing it again. We already have it up there. By this point in the year, my kids knew W and P really well. I bet y'all's do too. All right, so what are the parts? Yeah, shirts and socks. Okay, how many? Yeah, 4 shirts and a pair of socks. So we know the socks are $4.29. We know 4 shirts were 13. So here's what I would do. We're going to guesstimate. We're going to do 1 space for the pair of socks, which is $4.29. How many spaces do we need for the shirts? 4 is right. Do they need to be the same size or different? How do you know? Yeah, 13 each means they're each the same size. 4. They are $13 each. And I'm writing it 4 times because that's 1, 2, 3, 4 shirts. Each one, which is a grouping word, you either group them together or separate the groups. Well, multiplication. Yeah, I see repeated addition right here. All right, so this one's definitely a multi-stepper. How are we going to solve this? What do y'all think? We need to put these parts together to make a whole. So this equation, this equal sign, what do y'all think we should do first? A lot of kids may say to add all of them together. Yep, you want to add all of them together? Or, I think I wouldn't add all 5 numbers. So someone might say add these together. Well, that's true. Well, how many times would you be adding it? 4. Well, if it's 4 times, let's just say we're going to do 4 times $13. Now, we can add it over here, but let's write it like that. So that's 6 plus 6, which is 12. 2, 4 plus 1 is 5. So right there is $52. Is that everything? When you put these together, is that all of it? No, then we also bought that. So what do we do? Yeah, we add $4.29. The equations have an equal sign. If we do 4 groups of 13 and add $14.29, we're going to find the whole amount. Now, in third, I haven't really seen parentheses, but I have seen them link like 3 different numbers with 2 operations together. You could show them, parentheses, they just say, do me first. Like, I always got imagine me using my arms and I point to myself. I always put parentheses around my head and I'm like, me, me, me. So, I don't know if that makes sense, but if this is my head, I get my arms and then I'll put them around my head and go, parentheses say me, me, me. If that makes sense, or if you even could see. All right, so $52. Dollars, they stand in front of the decimal. $4.29. Well, that's going to be $56.29. So that's our total amount. So this is going to take the longest part, the strip diagrams, but I like it because on test, they may ask you to solve it. They may ask you to find the equation. They may use the fact family of the equation. They may give you the strip diagram. So this is very powerful because, plus I think the strips help them see part and whole, the sizes. They see the repeated addition. All right? And again, I made a lot of pages, but it's because they're large. And by the way, these are all copied in y'all's boxes. All right, so read this one for us, please, front row. So front row reads, all right, what are we looking for? We're looking for a number sentence to find chairs in classroom on parent night. All right, well, we're wanting to find the chairs. Do we want all the chairs or some of the chairs? Well, if we're wanting the chairs in that classroom, we're wanting all. Is all part of it or the whole amount? All would be a whole amount. Well, how do you get big whole amounts? Or first of all, are whole amounts big or small? Big. Well, how do we get big in math? We add or we repeatedly add. Okay, well, do we see any key words here? Well, twice is a key word to me because what does twice mean? Twice means 2 times. So the first thing I'd be doing is looking. That doesn't say 2 times. That has a 2 times. That doesn't. This does. There you go. So we know right now we've eliminated 2 just with that word. All right, what else do I know? I know there are about chairs. There are 6 rows of chairs. 1, 2, 3, 4, 5, 6 rows. All right, there it is. It's a fancy each. Per. I always told my kids, what is per? And they're like, it's a fancy each. Yeah, 5 chairs per row means 5 per row, 5 each row. Well, what are we seeing here? Repeated addition. Yeah, how many times? 6. So we want 6 groups of 5 twice. Don't even have to solve it. You just have to understand and understand your wording. Know if you're looking for part or whole. And I mean, my gosh, the most powerful math tool. Draw. When you are stuck, draw, draw, draw. All right? Back table or John's table, read us about Keith. So they read. By the way, you don't want one kid reading at a time. You want fluency. You want all the kids reading as much as possible. All right, we're looking for a model to represent sign Keith made. Well, what do I know about the sign? It's rectangular and it has a perimeter of 48. So there we go. Perimeter of 8. What word in perimeter is very special? Rim. Yeah, where is the rim? The rimmeter is all the way around. Or you could perimeter. 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 To find the rimmeter, we go all the way around. What is the formula? Perimeter is 2 lengths plus 2 widths. Because if you grab 2 lengths and you grab 2 widths, you're all the way around. If this one is 32, that one is 32. If this width is 16, this one is 16. Now, I do a little mental math here with my kids. I'm like, look up here. What's 2 plus 2? 4. Good. What's 3 plus 3? 6. So that's 64. Plus a 16 and a 16, right? 64 plus 16 plus 16 takes us all the way around. All right, well, here's a 10 plus 6. 16, 6, 7, 8, 9. So this is 96 inches all the way around. Is that what we want? No. What do we know about a square? Oh, they're all, congruent edges. 12, 12, 12, and 12. How many times do we repeat 12? 4. So this is 4 groups of 12. Well, look at your multiplication table that you made. And instead of looking it up and depending on that, 2, 4, 6, 8, 4. 48 inches. Is that what we want? Yes. There's your answer. All right. Class, read me this one all together. Read above and then below. So they read. All right. What do we want? Tell me what to summarize. I'm looking for value. Value of what? Digit 4. All right. So let's highlight the 4. All right. We want the value, not the place, the cha-ching. How much is it worth? You don't know how much it's worth, though, unless you know the places. So let's say our repeating places. You start with ones, then what? Tens, hundreds. Repeat. 1, tens, hundreds. And 1 comma says 1,000. All right, so this 4 is in the 1,000s. You have 4 1,000s. That is a value of 4,000, which is not here. And I would make them write it. Like I'd make them write that and then put that. See, that page is super quick. All right, this one, we've got a table, a T-chart. Tables are T-charts because they have a T. And before you ever read a question on a T-chart, you analyze this like a book. What's its title? Number machine. Good. Numbers are coming in, and then they're coming out. In, out. In, then out. In, then out. And notice that you have to start with their order. So it doesn't matter what order I want. I better go their order. Inputs first. So it's input to output, input to output, input to output. So I followed the right order. Input, output, input, output. So when you go from an input to an output, 1 to 15, 2 to 16, 3 to 17, are you increasing or decreasing? Okay, what does increasing mean? Yeah, you're going up. Well, what are ways to go up in math? You add or multiply. I agree. Well, look at these numbers. If you have a 1, what would you have to multiply by 1 to get a 15? Times 15. Well, then, by the way, if we're looking for a relationship, that means the numbers are following a pattern. And who has to follow the pattern in the class? Or who has to follow the pattern? Everyone. That's why it's called a rule. So I always would try multiplication first because, hey, you're big third graders. So if we do 1 times 15 is 15, then we need to see if 2 15s would be 16. Is that right? No, 2 groups of 15 is not 16, so it's not multiply, it's add. Well, what would I add to 1 to get 15? 14. Well, if I add 2 and 14, let's see, 14, 15, 16. Yep, if I have 14 and I add 3, 15, 16, yep. So the correct answer is A. All right, read us the next one, Bella's row or Bella's table. So she does, all right, what do we need to summarize? We want to estimate, show Daddy, estimate what? Difference what? Between potatoes and cucumbers in garden. So what are we wanting to look at? The potatoes and the cucumbers. So what's trash? Onions. Yep, onions are trash. Throw them out. Estimate. If I ask you to estimate, or if I said, what is the estimate? What does that mean? It means not exact, right? An estimate is not the exact number. It's close. So in other words, we're going to round. All right, well, what do I round to? It doesn't tell me. No, it doesn't. Normally, my rule is round to the highest place. However, with multiple choice, you need to look. Like that's 1 0, 1 0. 2 zeros, 2 zeros, 2 zeros, 2 zeros, 1 0, 1 0. So it could be that we're rounding to the tens, or it could be that we're rounding to hundreds. And that's not really helpful. So I would try hundreds first because my rule is round to the highest place possible. Why? Because the more zeros you have, the easier it is. All right, so which digit is in the hundreds? 3. So am I closer to 300 or 400? Hopefully they say 400. I'd ask my students, how do you know? Because my neighbor of 5 or more pumps up the score. All right, which digit is in the hundreds? 1. All right, are we closer to 100 or should we move up to 2? Hopefully they say 200. Why? Because a neighbor of 5 or more pumps up the score. Well, do you see a 400 and a 200 down here? No. So whether it's add or subtract, it doesn't matter. That doesn't work. So if the hundreds doesn't work, and I'd go ahead and do that even though you know it doesn't work, let's try the tens place. All right, are we closer to 70 or should we move to 80? 70, because the neighbor of 4 or less lets it rest. So everything rests in front. Tens place, are we closer to 80 or should we move up to 90? 90, how do you know? Because my neighbor 5 or more pumps up the score. 1 stays the same, so it's 370 and 190. The difference. If I want to know what's different about this than that, if I want to know the difference, that's not put them together. That's what's different about you than you. Answer to subtraction. Don't have to solve it, just have to know. And I love it when they show me symbols. My kids, when they saw estimate, they always did smiley faces because we know estimating makes our math easier. All right, let's read the next one. All right, we're looking for a number with 3 in the hundreds, 1 in the 10,000s. Well, let's start with the 3. Let's talk place values. All right, give me your places. 1, 10, 100. Repeat. 1, 10, 100. And then 1 comma says TH, says 1,000. Now that we know that, let's look for a 3 in the 100. 1, 10, 100. Does that have a 3 in the 100? No. 3 in the 100? 3 in the 100? No. Bam. Now I want to look for a 1 in the 10,000s. Not 10, the 10,000. So 10,000. Is that a 1 in the 10,000s? Nope. Is that? Yes. There's your answer. And then last but not least, see, a lot of them are real quick. They're just big pictures. Last one, girls, read me this one. All right, what are we looking for? We're looking for which shaded letters not area 18 square units. Not, man, when not's up, you better put your puppy dog ears up and pay a lot of attention because we are trained to circle what's right, not what's not right. Area, when I hear area, I need to think good, squarea. Where are the squares? The squares are inside. And you could find the length and find the width and multiply, except this is irregular. So we're needing to find the squares inside. So here's what I do. I just put check marks as I count. So we're going to count and go 1, 2. Do y'all see what I mean? All right, let's do it together. Catch up. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 square units. So is that what I want? No, I want the one that is not 18. Because this is right, it's wrong, which is why it hurts our head. All right, we can go here. Let's count by twos, like this. 2, 4, 6, 8, 10, 12. 14, 16, 18. 18 squares inside. I do not want 18 because this is right, it's wrong. All right? Now, I want y'all to look at C and Y and tell me what you notice and what's a problem here. C and Y have triangles. So I would tell my kids to maybe shade in the triangles. So I'm shading in the triangles. All right, well, here's what I want y'all to look at. See this one square? Squarea, right? If we divide a square into a diagonal, what do we make? 2 triangles. Okay, so 2 triangles makes 1 square. So the way I would do this is I would connect. There's 1, right? 2 triangles make 1 square. So 1, that's another 1. So we have 3 squares. 1, 2, 3. Now let's start checking. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I missed this. 14, 15, 16, 17, 18. So it's got to be this one. So I've got 1, 1, 1, 1, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Not 18 squares. All right, the next to last one, we've got another table. What are tables? Tables are T-charts. Well, what's this T-chart about? Postcards. What do these digits represent? Packages. What do these numbers represent? Postcards. All right, what do we want to do? Or what are we looking for? We're looking for total number in 8 packages. So you need to follow what you're doing. Total. If you want the total, do you want to get big or small? Big. How do you get big in math? You add or you repeatedly add. All right. Well, we want the total for 8 packages. Here's your packages. Is there a number 8? Yes. So you need to move from 8 to the postcards. So we're moving left to right. Let's look at what we see. 2 to 24. 6 to 72. 10 to 120. Are the digits getting larger or smaller? They're getting larger. All right. Well, if they're getting larger, we need to get big with either add or multiply. Which one should we try first as big third graders? Multiply. All right. So I'm thinking, what times 2 is 24? And this is where they're going to have to know their facts. If they don't know, I'd make them start counting by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. How many 2s is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 2 groups of 12 is 24. Is 6 times 12 72? I don't know. Well, let's see. I'd come off to the side and work it then. 12, 6 plus 1. Ah, so our rule is packages times 12 equals postcards. So we want 8 times 12. Well, if I know this is 6 12s, I want 8 12s. So that's 6 12s. That'd be 7 8 12s. 2, 4, 6, 7, 8, 9. Or they just know their facts because y'all have worked them. Or they made a multiplication table and they used it. All right, so 96. 1, 10, 100. There's no 100. It's 96. Bubble, record, and bubble. All right, last one. We want the total number marbles. 8 bags. If you want the total, Kayla, are we wanting part or whole? Whole, good. Ethan, if we want a whole amount, are we getting big or small? Good, we're getting big. Stockton, how do we get big in math? Add or multiply. Good, let's look for keywords. Each, very good. Each means group them together with multiplication or take each group apart. So, which one jibes with what we want? Multiply. You know why word problems are hard? They're hard because they're words. How do we make it easy? We draw. We want the total for 8 bags, right? Well, I don't see the number 8. Ah, it's because 5 plus 3 is 8. So draw 5 bags. Draw 3 bags. No. 5 bags, 18 marbles in each. 18 in each. What are we going to be seeing when we plug in 18 in each? Hopefully they say repeated addition. Good. How many times? 5. All right, so this is 5 groups of 18. All right, 3 bags, 13 in each. When we plug that in, how many times do we see 13? 3. Good. So 5 groups of 8. 5, 10, 15, 20, 25, 30, 35, 40. 40. Do we need to carry? Yes, because the number's waiting. Then 5 groups of 1. 5 plus 4, 6, 7, 8, 9. So here's 90. By the way, look how it's probably, yep, it's waiting right there. It's waiting for the kid not paying attention. Is this 8 bags? Nope, it's part. 3 threes. 9. 3 groups of 1, 3. So 90 plus 39. That's the 5 plus the 3. Part plus part equals whole. That's tomorrow's math. And then Friday's is going to look a lot like 4th grades. I'll quickly show you just so you kind of get an idea. 4th grades, and I'll have it ready for y'all at conference, but I'm thinking Friday I'll put multi-steps up, and so they can start at any station. There'll be like 10, 12 stations. They start at any station, so I'd start at A, and then I work this out in the space, and then A's answer will be on another station. and you need to go to that other station. And when you find the answer, well, that's V. So then you'll put, well, I went to letter V, and then you'll work out V. And when you work out V, V's answer might be over here on R. So it's kind of like a little scavenger hunt. I'm thinking that's what we'll do Friday. So tomorrow's another day of working together, and then Friday is a scavenger hunt. I always told my kids, and this kind of helped keep them motivated if they didn't want to participate. If you actively participate, first of all, you know I'm going to give you dojo, but also if you're really helping me out, I promise I'll partner you with someone who is also being helpful. That way you're with someone that's going to work. If you're sitting there being a dud or not helping, then I'm going to put you with someone else that's not helping, and good luck tomorrow when you're together, because you're not going to cheat off someone else. And that always kind of helped a lot, I think. Okay. Night, night.